This is another episode of Giant Global Graph. I'm your host Adrian Gschwend, and today I want to show you a little bit what I did with my Internet of Things devices and RDF. I had a lot of fun. It's actually something I wanted to do for a really long time, but I never took the time. But now I can show you quite some nice things we can do with IoT integration and using at least part of the things we can get in there with RDF. So I'm using Home Assistant. Home Assistant is a open source IoT software, which is really popular. A lot of people are using that. And when you buy an IoT device, there's a very fair chance that you can get Home Assistant support for it, at least when the software or the device is more or less open and has some kind of API. What Home Assistant also provides is a way to basically program your own firmware on devices. So I have a lot of Sonoff smart switches here in the house. So basically everything is using Sonoff, and I can turn on and off directly on the firmware from the Home Assistant project, the devices. That's not the primary purpose I want to show you. What I want to show you is what we can read out from these devices. And in this case here, I have, for example, the air conditioning. I definitely need air conditioning where I am right now. It's really hot here, so I couldn't live without that. And I want to know how much do I use the aircon? Can I maybe figure out how much energy I used, things like that. I also have another device we will see. This is the Xiaomi air purifier. I'm in a big city here and the air is really bad. So in-house I have a air filter which takes care of that. So I will not go into the details of the Home Assistant setup. Just assume that I've set everything up as described in many guides for Home Assistant. YouTube is full of videos for that. And what you can see here is that I have a little dashboard which shows me some graphs from these things. And I was not really happy with that. That's not super well done in Home Assistant, and it's not really fun because I wanted to have the raw data and do something on my own. So you can see here that I have the humidity for my air conditionings. I have 4 of them in the house. And here I have the temperature from the air filter. So the Xiaomi also has a temperature sensor in it. So I wanted to read out these things and I had a look at various ways of doing that. And in the end, I found Node-RED and I started playing with Node-RED. Node-RED is a Node.js based software which basically is used for API integration, or at least that's what they say on the homepage. It was relatively easy to set up, so I have a Docker container which is running Node-RED, and I installed the Home Assistant nodes in here. So when we scroll down somewhere here, I see that I have the Home Assistant integration for Node-RED. So in my Home Assistant setup, I had to give an API key, I had to create one, and Node-RED is using this API key. But the only thing I actually really use right now is this one here. I think it's the event all, yeah, this one here. So the node says it listens for all type of events from Home Assistant. It's super generic. So every time something changes in my house, there will be an event fired within Home Assistant. And with that integration, I can get this event into Node-RED. So the whole Node-RED thing is very much event-oriented. And as you can see, I do have some debug wiring here. So from time to time, you see something popping by. This is when something happens. And just to maybe prove my point, let me switch something on my phone. You already saw that the Xiaomi gave an update. Let me just turn a light on and off so you will see that there's an event happening as well. So I turn the light on and I turn the light off again. This is the light which you see here at the end. But most of the events are not really interesting for me. But what's really cool in here, from time to time, I see events which are actually of interest for me. So for example, this one here, I can copy the JSON from this event and I can throw that into something which pretty prints this. And then I can see that this event apparently is about the Xiaomi motor speed. So it gives me the state of the fan in the Xiaomi air filters. So every time this for some reason adjusts, I get basically an update on that. And that's very cool. And that's basically what I started doing here. I started figuring out the events I'm interested in, and I started to create a workflow which converts this stuff to RDF. And that's basically the thing I want to show you. So I get all these events in here, and I selected the ones I'm really interested in. I want to take some of these events and convert the data into RDF and write it in a SPARQL endpoint. I will show you what I do with that later. But first, let's see, how do I get from these events, which are extremely ugly JSON structure, how do I get that into RDF? Side note, I really hate JSON, but we have to live with that. Pretty much everything in this domain is using JSON structures. So the first thing I did is I created the event ID logger. For that, I used a node in Node-RED. It's the so-called change node. This is this one here, the function node change. Set, change, delete, or move properties of a message. So this is very nice when you quickly want to pick something and log something. So after having a look at the raw message, so initially I only connected the raw message to the debug thing here, and then I get the full thing, the one we just had a look at. So here I quickly made a logger which just gets the event ID, because I only wanted to see what kind of different events do I get. So I could cherry pick the ones from the devices I was really interested in. And I started with the air purifier temperature. So I figured out which one was the event for that. And after I had that event, I did what I showed you here. I went into the JSON, had a look at the structure, and then I needed to read it out. So the result you see here is basically several iterations of refinements. What I do now here is I use another change node, so a very generic one, which takes this super ugly structure here and extracts the few things I'm actually interested in. And in my case, without going into too much details, I need to say that entity ID, is the entity I'm caring about, for example, the temperature change of the Xiaomi. Then I need to read out from the new state, the state. So you see we have commonly ugly JSON structures, but apparently I always get the old and the new state from Home Assistant. And the most generic one is simply you get the field with state and then the value. Then if you want to understand what this stuff is, most of the time you get some attributes which basically gives you the semantics of the structure. So in this case, for the speed, it's RPM, probably rounds per minute. So how many times does it turn around per minute? And that's what they call the motor speed for this thing. So that's what I did. Let's have a look at the temperature node. We go in here. And what you see here is a so-called JSON-NATA structure. JSON-NATA is basically XPath for JSON. This is something some people created. It's extremely useful when you have to work with ugly structures like this. And I can show you here in an example. This is the pretty printed version of the energy usage of my air conditioning. It's called Delta Energy, the entity ID. And I get in the new state, the state 0.051, and this is kilowatt hours. So since the last time I got the state, it spent 0.051 kilowatt hours on energy on this aircon while running. And with this JSON-NATA structure, I'm not going into the details, but with this JSON-NATA structure, I can basically move that into a better JSON structure. So simply assume that these structures, they take the big JSON and they create a very simple key values JSON. And you can see what I actually create is even hard-coded for a big part. I have a key which is called sensor ID. This is the Xiaomi Air Purifier 4. This is the device. I have a generic key which I call property. And in there I say temperature. We will see why we need that later. and I have the value of that property. So what's the value measured for the property temperature in that case? And here I read out the new state of this thing. And then because we do RDF, I will create some IRIs. So I made an entry which is called observed by IRI. I will talk about that later. And the same is for room IRI. And this event will only trigger if this entity ID here is matched. This is what this expression does. It's basically a if-else expression in JSON data in this query language for JSON. So this is very nice. When I do that in this step, it will create this simple JSON structure, and this JSON structure will be fed to a so-called function node. A function node is basically a node where you can have whatever JavaScript code you need. You get as input the message, among others, with the payload. The payload is basically what you get from the previous step. So the payload contains this JSON structure you just saw created in the previous step. And the interesting thing is how I did that. I'm not really the programmer in our company. I'm really good in RDF. I'm not really good in coding. I pretty much didn't write a single line of code myself here. I completely worked with ChatGPT and told GPT what I should do. I had an idea of what I wanted to create, and I wanted to create a turtle observation of this event. And I simply told ChatGPT, this is the expected result. That's the input you get. Write me code which maps this to that. And after some iterations, we had a very nice generic function, which I now use for everything. Let's quickly walk through. So here we just make sure that all the input I need is set. If not, we simply return null. We don't care. Then it's not our event to handle. If so, we assign these things to direct access properties again, variables, and we give the whole thing a new timestamp. I noticed that I could read out the timestamp in Home Assistant, but in another device I'm using, I don't get a timestamp. So I decided that we just create a new timestamp from whenever the event is triggered and arrives here in this function node. Then I have some base IRI, which I use. This is my internal domain here. And I create basically a cube observation. I will quickly show you what we do here. Once this string is done, so this is basically just the template string which gets filled out by these values which I get from the previous step. That's it. So it just creates a string this step here. And then I had to I figured out that I have to set the content type because I want to write that actually to a triple store. So the message payload is turtle and the header is content type text turtle. And then I return the message and hand it over to the next node. Again, that was 100% ChatGPT writing the code based on my input, based on my requirements. I think this is extremely cool. It's actually really good in Node-RED. It seems to understand quite a bit of Node-RED, so that was super useful. I actually asked it, like, how should I do that? It told me which nodes to use. It told me that I need to use a function node for that. And it even wrote the initial JSON data expressions. I didn't have too much experience with it. In the end, I was faster adjusting it myself, but the initial expressions ChatGPT did. So to give you an idea, I simply take stuff like that. Let's go to the chat and tell him, like, given this JSON input, what would be the proper JSON data structure to extract the, what was it? Power delta. Yeah, okay, that's, no, it's a bit uber eager. It wants to calculate the difference. That's not necessary. But anyway, you get the idea. I really can post even ugly JSON structures and tell it to extract this, write the JSON data structure to map it from this form to that form. I gave it both forms I wanted, and it does that for me. Good. So once we have that, we have basically turtle, and I think I don't log it anymore. Let's quickly log it so you see how it looks like. I can trigger it manually. Yeah, here. Here I have an inject node. This is nice for debugging. So here I basically paste the structure while developing, and then I can trigger this one so it acts like there is an event happening, and I use the same step or the step I'm working on, but the output is written to the debug node. So let's quickly do that. Now I got something, and I see it writes exactly the structure I was mentioning. Let's quickly have a look at that in the pretty print. So this is this simple structure I had: sensor ID, property, value, observed by IRI, and room IRI. And if I now connect that to the IoT cube observation step instead of the debug one, or additionally to the debug one, that doesn't really matter. Then I need to deploy this new version. And if I do that now, I should see the generated turtle as well. This is this one here. Can copy that. And let's quickly look at that in Sketch. Yeah, this is super nice here. So we have a IRI, which is a cube observation. It is cube observed by this device. It's in the room here. The temperature is 27 degrees, and this is the timestamp. And that's exactly what I wanted to do. What kind of structure is this? This is a very simple cube structure. It's similar to the data cube vocabulary. If you worked with the older versions, this cube vocabulary is something we created at Satsuko. All the things we create right now in cubes is based on this model. It's basically a more modern version of the RDF cube vocabulary, using advanced features like shackle and being less confusing than RDF cube vocabulary was. I'm not going into the details here, but we basically have is you have a cube has an observation set, and then you have a bunch of observations. And in this node red thing, I simply create one observation. So every time something changes, some new event comes in, it adds an observation to the cube. Let's go back here. So you see that meanwhile there was another event coming. This was one that got really triggered. Let's quickly have a look at that. So that was not a test event. What was that? That was the air purifier in the living room, and it told me the temperature is 28.6 degrees and another timestamp. So that's what I save. How do I do that? That's actually extremely simple. I was thinking a bit about the setup. It's straightforward. It's all in my local network here. I didn't care about security for this part. So what I did is I bootstrapped a Oxigraph server. I really like the Oxigraph project as well. This is a lightweight binary SPARQL endpoint, triple store. And I quickly bootstrapped that on my small device via Docker as well. So no authentication. It's in my intranet on a machine on this port. And I can simply write via the SPARQL graph store protocol to this endpoint. And if you have a look at this step, this is a generic HTTP step, which we have. This is the HTTP request step. You can see that based on this icon here. And all I do is I provide the IRI of my triple store of Oxigraph with the correct database and graph. So it goes into the database store. Seems to be the default one. I didn't change that. And it goes into the default graph of that thing. And because we want to append things, I have to use the post, not the put. With put, I would delete the existing graph, but every time I get a new event, I simply want to append that to that. So that's really all what happens, and this basically persists this turtle which you saw in RDF in the triple store, and I get more observations the longer I let this thing run. Now let me quickly delete the debug. I don't need that anymore here. So let's deploy that version again. And let's look at Oxigraph. So let's first do a observation. You saw the structure before. I have a cube observed by, that's basically the device which did the observation. So you can filter by device. And you can also filter by room if you want to. Every device in my setup, that's the way I designed this cube, is assigned to a room. And then I have multiple observations per device. So in this case, the air purifier provides temperature, humidity, PM 2.5. That's the air quality. And I think there is a PM 10, but I haven't seen this event yet. I'm not sure if it's in there or not. So these are the things I basically store. So let's quickly have a look at querying this. I have a query prepared. This one doesn't go on the Xiaomi. It goes on the aircon in my bedroom. And it's actually locked to the delta energy. Let's quickly change that to DH temperature. I just made up that vocabulary. That was not something, or is not something existing. Temp. So if I do that, I basically see the series of temperature observations. I by now have 57. I didn't start that long ago. And the aircon is actually, I don't get too many events. I noticed that it also only has like 1 degree values. So you don't get any details here. It's 29, 28, 27, 26. That's it. That's all I get from the aircon in my bedroom. Or actually, the aircon in general, I always use the same model. But you can see that I have 57 results right now. The first one was on April 16. Now is April 18. So it's not that many. It's only 57 events in this time. When we go to the Xiaomi, let me quickly see the devices. So here I have a query which gets the distinct list of devices. So let's copy that link here. And let's replace the device with the Xiaomi. Oops, that's too much. So here, so let's have a look at that. Remember, the bedroom AC only have 57 results. The Xiaomi sends me much more events. It's already almost 200 in a bit less than 3 days. So here I get more events apparently, and I get point something results as well. So it's a bit more detailed than what I get from the aircon. So that's the principle. This is extremely simple. It's super flexible, and SPARQL is a super nice language to query this data. You can do really cool stuff. I will quickly show you what I have in mind. This is all a bit work in progress. So also here we can use ChatGPT. Let's go back to the delta. I copy that. Let's go into a new window. And let's not care about the temperature, but the delta energy. So, and this is on the aircon and not on the air purifier. I don't get any energy reading on the air purifier because the real energy hogs here are the aircons. This one I want to copy, sorry. So I want to query this one here. And now I need to delete this. Good. So this looks good. And this is actually energy. Good. So this aircon, or every aircon I have, is reporting the delta energy usage. I called the property delta energy, and it seems to be in kilowatt hours. So this means that within this and this measurement, the delta energy usage is 0.083 kilowatt hours. So that's the energy burned in that period. So I was thinking, this is actually cool. I could quickly see how much energy do I use during the night, where the aircon in the bedroom is set to my sleeping temperature. So I know how to write this query. This is a sum query. I need to do a group by, but we have ChatGPT these days. So I asked ChatGPT, So basically I tell him what I need, and my experience with ChatGPT is you need to give him some input. The more you give concrete input, the better the chance that it actually does something useful. And I'm really curious. I'm now on model 3.5, so on the older one. I think the last time I did it on 4, so let's see how it goes here. I ask it for the given SPARQL query, can you sum the energy usage within the past 24 hours? Let's see if it understands that. You have to play with these things. You get a feeling what works and what doesn't work after a while. And I don't want to confuse it. I'm not sure if it reads the command properly. So I select the date, the energy, and the device, and it does only order by, so I want to have a sum. It needs to be an aggregation for that. Okay, so let's quickly look at the thing. It does a sum energy as total energy. That looks already good. It does a group by and the order by, and it has a very nice filter for the 24 hours. This looks cool. So let's copy that and try it in Oxigraph. Let's open in a window here. Okay, we get an error and XSD. So this is also funny. ChatGPT is a bit sloppy. It didn't notice that it forgot to define the XSD prefix. Some triple stores just assume some standard prefixes, but it should add that. But that's easy. We know Yasui. We just type XSD double quote and it will add it. So I can delete this already. And now the query is valid. So let's see what it does. It calculates that within the last day, this is actually XSD duration. It's quite impressive to see that it does it like that. It says between 1 day, now minus 1 day. So I have the 24-hour window, filter all the observations, and then group by device. It would even group that by device. That's quite cool. I didn't ask that to. But sum up the energy as total energy. Yeah, why it didn't group why it did group the device is a bit strange because I don't have a device in it. Did I had it in the input? Oh yeah, my bad. I had the device in here, but it wasn't a variable, so that would make sense. But I could actually do that for all. We can try that later. So you see for the bedroom AC within the past 24 hours, I burned 3 kilowatt hours of energy. And now just for the sake of admiring that it added the device, let's add the device here and comment this then. So now it should do it for all the devices which provide the delta energy. I think that should be 3 or 4. 3. So we can see that the AC in my bedroom burned 3 kilowatt hours, the one in the living room 3.4, and the absolute energy hog, to no surprise, is the one in the mezzanine. That's the hottest room. That's the one which has a rooftop window and it heats up like nuts. And this is where I work. This is where I sit right now. So here in these 24 hours, I burned almost 9 kilowatt hours. That's quite impressive. I think that's pretty much it. The last thing I want to show you, but this is an episode for another time. I actually pushed ChatGPT to build me a visualization. Again, I'm not a front-end programmer. I'm not a good programmer in general. I'm very good in SPARQL and RDF and everything related to it, but programming is not my strong suit. I could actually, by talking to the ChatGPT 4 model, I could create this visualization here. It actually shows me the outdoor temperature of another sensor, which you didn't see yet. I have another pipeline for this one. This is a Zigbee-based outdoor temperature sensor, which reports via the Zigbee protocol the energy. And it quickly visualizes that using chart.js, a chart.js library. So I asked ChatGPT what library should I use. It gave me some options. I decided to go for chart.js. It created me a bootstrapped version with some dummy data. And in the end, I managed to get my SPARQL query into this and have the SPARQL query executed against the Oxygraph store and render the result like this. So I found that super cool. I didn't write a single line of code. I don't understand half of the code it gave me, but it's super, super cool that we can do things like that now. This will really help interacting with RDF SPARQL and all the cool stuff we can do. And as you can see, I had a really hot day yesterday. It was 36 degrees on my balcony. That's not even on the sun. Today is a bit more bearable. We had 32 degrees. And with that, I close this session. I hope you enjoyed that. I will keep you up to date on what I do, and I will show you a bit more how I use ChatGPT for creating very cool things with SPARQL. See you next time.